Welcome to Day 5 Notes. Today's learning target is I can calculate the slope of the line given 2 points or a graph of the line, including the special cases of horizontal and vertical lines. So this graphic organizer should serve as a review. So remember, slope is the steepness of a line, and in the math language we use the lowercase m to denote slope. So we're going to review how to calculate slope given 4 different types of information. So let's first talk about a table of values. So here I have an XY table of values, and I want to recognize and calculate the slope from it. So what we're going to do is we're going to find the change in y over the change in x. So let's first talk about the change in y. So what's happening to my y values as my x values increase? And I think we would realize subtracting 4 each time. So a triangle means change, so change in y. Make it equals -4. Okay. And so we're also going to look at the change in x. So what's happening as my x values as we move along the table of values? And I think we would all see that we're subtracting 6. So our slope is always going to be the change in y over the change in x. So as I do work over here, should be a 6. Okay, and then we're always going to look at our fraction and see if we can reduce it. So I have -4 over -6, which reduces to 2/3. So my final answer would be 2/3. Again, big idea is that y, it's our rise over our run. So y always goes first, and it will be in our numerator. Okay, we can also recognize and calculate slope from a graph. So we have a line here, and we know it's a linear function, and we're going to choose 2 points on the line. The rate of change is constant, remember, so it doesn't matter what 2 points. I would recommend finding points that have that intersect and are nice, pretty integer numbers. So we're going to find 2 points, so I'm going to choose 1, 2, and let's go down. Oh, I like this one right here, 0, -1. And we're going to count the rise, then the run. So we're going to write slope as a ratio of rise over run. So let's talk about rising. So I am going to go up 3. Okay. And I went up in the positive direction, so that's why it's a +3. And then I'm going to run, okay, 1 unit in the right direction, which is positive. And so again, m equals 3 over 1. As I reduce it, equals 3. So my slope is 3. Okay, you can write over 1, but it's not needed. Also, as we look at this line, I knew my slope was going to be positive because it increased as I read the graph left to right. So from a graph, we calculate the rise over the run. Another way to calculate slope is if we're given 2 sets of points. So this formula may and should look familiar. We're going to use the formula m equals. Now remember, it's rise over run, so we're going to change the change in y over the change in x. Okay, and you'll notice that I use x or y sub 2, y sub 1, x sub 2, x sub 1, and those just denote 2 points. So if I was looking at this equation, these 2 points over here, this is like x1, y sub 1, x sub 2, comma, y sub 2. The order we write them in doesn't matter, we just have to be consistent. So we're going to calculate it, we're going to simplify the numerator and denominator, and then we're going to always write the slope as a ratio or a fraction, whichever one you prefer. They're the same thing, and so let's calculate. So I have 2 points, and I don't have a graph, and I don't have a table of values, so we're going to use the formula. So I'm going to start with m equals, so y sub 2, so I'm going to take this value, so 2 minus my other y value of 4, right here, okay, and then I'm going to subtract my denominator. It's going to be my change in x, so -1 minus 6. We're going to simplify across, so 2 minus 4 is -2 over -7, which then becomes positive 2/7, right, because negative divided by a negative is a positive, so my slope is positive 2/7. So that means if we were graphing it, I'd rise 2, run 7. Okay? Here's another example. So from 2 points, again, x1, y1, x2, y sub 2. So my slope m equals difference of my y's, difference of my x's. So my numerator, I have negative 12. Remember, minus a negative becomes a positive number. So we're going to have a negative 2, which reduces to a positive 6. So my slope is a positive 6. Okay. One thing I want to point out is if you were to calculate the slope and maybe you switched the order of the points and made this x sub 2, y sub 2, x sub 1, y sub 1, the slope is still going to be 6. The order you write the points in doesn't matter, but we just have to be consistent and make sure we keep the same x and y from each point together. Okay, so again, this formula is really important. If you make sure you box it, highlight it, memorize it, you have to know how to calculate the slope from 2 points. Okay, the last way is recognizing the slope from an equation. So what we're going to do is we're always going to rewrite the equation to solve for y. Okay, and then the slope is the rate of change. Therefore, it's going to be the coefficient, which means the number in front of x. Okay, so here, notice on the first 2 examples, so remember we said slope's the rate of change, it's the coefficient of x. On the first 2 examples, y is isolated, and so what I know is that my slope is the coefficient of x. So in this example, slope's 1/2. I recognize my slope as negative 3. But notice on this last example, y is not isolated, so I don't know the slope yet. So what we need to do is isolate y. So we're going to use some inverse operations. So the first thing I'm going to do is subtract 2x to move it to the other side. So I get 3y equals negative 2x plus 6. Again, my goal is still to isolate y, so the inverse operation of multiplication is division. And so I get the equation y equals negative 2/3 x plus 2. And so now I'd be able to recognize that the slope is negative 2/3 because now I can recognize the coefficient. So the slope of this line, m equals negative 2/3. Okay, so sometimes when you're calculating slope, it does require you to rewrite the equation, but once you have y isolated, you can identify the slope because it's the coefficient of x. Okay, so that summarizes the 4 ways to calculate the slope. So from a table of values, from a graph, from 2 points, or from an equation. The other key point is just understanding that there's 4 different types of solutions we can get. Okay, we could have a negative slope, which means it's decreasing, so we'd have a straight line, something like that. We could have a positive slope, which means the line's going to be increasing from left to right. Okay, and then we have 2 special cases. So one special case is a slope of 0. So think about that. That means an incline of 0. So we have a horizontal line. Okay, we also have a slope that's undefined. And what that means is that it's going to be a vertical line. Okay, and so in the next few examples, we're going to figure out how do I know when I have a slope of 0 or undefined.